What if AI could test your web app like a real user? Not by staring at screenshots and guessing, but by opening the browser, reading the page structure, clicking controls, filling forms, checking validation messages, and writing down what happened. That is the idea behind an AI browser testing agent with Playwright MCP. This is not a replacement for your regression test suite. It is a practical workflow for exploratory testing, smoke checks, bug reproduction, and turning repeated agent steps into deterministic Playwright tests. In this tutorial, we will build the mental model, the setup, the testing prompt, the demo flow, and the safety rules you need before you let an agent touch an enterprise web app. The demo scenario is a common QA flow. The agent opens a staging web app, logs in with a test user, navigates to a registration form, checks which fields are required, submits invalid input, verifies that validation messages appear, captures a screenshot, and generates a short report. That sounds simple, but it covers the hard parts of AI-assisted browser work. State, navigation, accessibility labels, timing, test data, screenshots, and evidence. The output we want is not just the sentence, "It worked." We want a report that says what the agent did, what it observed, where it found a problem, and which steps should be converted into stable, automated tests. First, separate the pieces. Playwright is a browser automation framework. It can open Chromium, Firefox, or WebKit, click elements, type text, wait for navigation, and capture screenshots. MCP stands for Model Context Protocol. In this workflow, MCP is the bridge between an AI client and the browser automation tools. Playwright MCP provides browser tools to an agent and returns structured accessibility snapshots of the page. That means the agent can reason over roles, labels, text, and element references instead of relying only on pixel vision. This matters for testing because accessibility snapshots are closer to how a well-built application should expose itself to users and automation. The key difference is how the agent sees the page. With Playwright MCP, the default interaction model is snapshot-based. The tool returns a structured accessibility tree. Buttons, text boxes, links, labels, and references the agent can use for the next action. A screenshot is still useful when you need visual evidence, layout review, or a before and after record. But for most interaction steps, the snapshot is faster and more precise than asking a vision model to infer what is clickable. If your application has poor labels, missing accessible names, or generic button text, the agent will struggle. That is a useful QA signal by itself. The setup pattern is straightforward. You configure your AI client to start the Playwright MCP server. That client might be VS Code, Cursor, Claude Desktop, or another MCP-capable environment. The exact config location depends on the client, but the idea is the same. Define an MCP server named Playwright, point it at the Playwright MCP package, and let the client expose browser tools to the agent. For enterprise work, use a staging environment, a test account, and test data. Do not point an exploratory agent at production unless your organization has already approved that risk. Also keep secrets out of prompts. Use environment variables, test credentials, or pre-authenticated state where appropriate. A weak prompt says, "Test my website." A useful testing prompt is much more specific. Tell the agent the target environment, the page or workflow, the credentials policy, the test data boundaries, the expected behavior, and the evidence you want back. For this demo, the prompt says, use the staging URL only, do not create real users, navigate to the guest registration form, check required fields, submit invalid email and missing name, capture a screenshot after validation, and return the exact steps, observations, failures, and suggested Playwright assertions. The prompt should also ask the agent to stop and ask for confirmation before destructive actions. That one sentence prevents a lot of avoidable damage. Now the agent runs the workflow. It opens the login page, uses the snapshot to find the email and password fields, enters the test credentials, and submits. After login, it navigates to the guest registration form. It inspects the labels and fields, submits the empty form, and verifies that required field messages appear. Then it enters an invalid email format and submits again. At this point, we ask for a screenshot because the validation state is visual evidence. The final report should include the path taken, the data entered, the validation messages seen, the screenshot file, and whether the behavior matched expectations. If the agent cannot find a control, that is not just an agent problem. It might be a labeling problem in the app. Here is the important engineering line. Successful agent exploration should become deterministic tests. The agent is great for finding a path, trying variations, and producing a first report. But your regression suite should be explicit code with stable assertions. Once the agent identifies a valuable path, write a normal Playwright test. Use role-based locators where possible. Assert the exact validation messages. Keep test data controlled. Run it in CI. This is how you avoid building a flaky testing process around a probabilistic agent. The agent helps you discover and draft. Playwright tests protect the behavior over time. The biggest risk is not that the agent clicks the wrong button once. The bigger risk is overtrusting its summary. Force the agent to separate observed facts from assumptions. Ask it to include the exact labels it interacted with, the validation messages it saw, and the screenshot path for visual states. If it says a test failed, it should show the step, the expected result, the actual result, and the evidence. For bug filing, require human review. A QA engineer should look at the report, reproduce the issue if needed, and decide whether it is a real defect, a test data problem, or a prompt problem. Common issues show up quickly. SSO and MFA can block automation, so use test tenants, bypass policies approved for automation, or pre-authenticated browser state. Dynamic selectors can confuse both agents and tests, so prefer accessible roles and labels over brittle CSS selectors. Slow loading pages can cause the agent to act too early, so instruct it to wait for clear page states. Browser sessions can leak state between runs, so reset storage and test data. Screenshots can be misleading if the page is still loading. And most importantly, do not treat the agent output as the source of truth. It is a QA assistant. It can speed up exploration, but stable release gates still need deterministic tests, clean environments, and human judgment. The agent report should be structured enough that a developer or QA engineer can act on it. Include the scenario name, status, steps, test data, observed behavior, expected behavior, screenshots, and suggested Playwright assertions. This format makes the report easy to review and easy to convert into tickets or tests. If your team already uses a test management system, map these fields to that system. If you use pull requests, attach the report to the bug or the test change. The point is to keep agent output from becoming another loose chat transcript that nobody can audit later. To recap, Playwright MCP lets an AI agent interact with web pages through browser automation and structured accessibility snapshots. That makes it useful for exploratory testing, smoke checks, bug reproduction, and test drafting. The safe workflow is simple. Connect the MCP server to your AI client. Use a staging app and test credentials. Give the agent a constrained testing prompt. Require evidence, steps, observed messages, screenshots, and suggested assertions. Review the output, then convert valuable paths into deterministic Playwright tests. That is the practical balance. AI can help you explore faster, but your release confidence still comes from stable tests, good environments, and human review.